we can start. I don't see all developers here, but I guess that they will join later on. A couple of them have noticed that they will be late. So I will share my screen so that you can see the presentation. Let me see yourself here. So this is actually sprint review meeting 26, and we are going to demonstrate the core functionalities we have implemented to Local EGA. And about today's agenda, at first Niklas is going to tell something about the project, and then we will show demos, actually 2 of them. One of them will be shown by Fred, and Dimitro will show the second one. And after that, we discuss a little bit that what we are planning to do in the future. So, Niklas, please go ahead.
Right, thank you. And I'll ask you to move these slides forward. So, first off, a very brief introduction for those with the EGA. Maybe everyone that's not can mute.
There you go, I muted it. Okay, so CSC people is now or are now muted, so you can continue.
Thank you. So the EGA then stands for the European Genome Phenome Archive. It's an archive for sharing controlled access human data in a legitimate way, making it possible to reuse human genetic and phenotypic research data with other researchers that have a legitimate need for it. And the control of the deposited data is controlled by the data submitters themselves, not by the archive. I think this is a very important part of this. This archive has been running for quite a long time, and it's hosted at 2 sites, at the EBI as well as at the CRG in Barcelona. Oh yeah, so next slide. Right, so in a schematic view, the EGA has looked like this for quite a long time, quite simple. Well, anyway, that the submitter would use a web interface to submit the data. Other researchers would search the metadata to find interesting data sets and ask a data access committee for the data set if they can have access, and then they're granted access, and then download the data and do the research on that. So if we move to the next slide, with the advent of the Elixir Accelerate project, there's been formulated a plan to enhance the functionality of the EGA for the future research, and to make it distributed, cloud-based and accessible in many different ways. And I'm not going to go into all the details of that plan, but one part of that plan is the distributed part, and what is often termed as local EGA, where we can have local instances hosting the data. So if we move to the next slide, basically, push one more forward. So the data is then hosted locally at local instances, and there can be many of these. And next. The metadata about those data sets are hosted centrally, making them discoverable regardless of where the data is hosted. And the access to the locally hosted data should be as seamless as possible for the requester. Right, next slide. So in parallel, the Nordic Elixir nodes have been running a project on collaborating on sensitive data that's called Trygve, which is now in its second iteration. Next slide. And in this project, the aim is to facilitate cross-border biomedical research using sensitive data and making it possible to access proper infrastructures for this. Next slide. And this project is now in its second iteration, and it's been recognized that the archiving of sensitive data is a very important part of this. And so one of the key deliverables is sensitive data archiving. So we're putting resources then on the next slide to develop a code base for archiving of sensitive data that should go hand in hand with the Elixir Accelerate Work Package 9 1.2, the Local EGA deliverable. A code base that should be packaged for convenient deployment at other sites, and it should support some core processes at least, and other relevant processes for the members of the Trygve project. So that is the core processes being data in and data out, described simplistically, and the federated querying, which will be then of course implemented in centrally. And also a part of this deliverable is to establish what we call pilot production instances of these services in the member nodes. So next slide. Yeah, so just briefly when we say core processes, first is that a submitter can register at the central EGA and also specify which local instances he or she wants to deposit data in. And that should then be possible to have an inbox at the local EGA instance. Then the submitter uploads data to the local instance and makes a submission through the central EGA portal describing the data sets with the metadata, and that leads to dataset archiving at the local EGA instance. And the third core process is that a requester has registered at the site and asked for and been granted access to a dataset at the central EGA portal. That should then make it possible for that requester to download the data from the local instance, either by HTTPS or a real-time decryption access or HTS GET streaming are the protocols that we are, in the first instance at least, supporting. So so we can move on. Right, so this is just the team that has been working on this from the member nodes. We also collaborated very closely with the people in Barcelona and in UK. If you move on, yes, we have the guys there, and Joa and Fred, if you click again, have collaborated so closely that they even moved to Barcelona for, it's over 6 months now, I think. So that's been very good for us, I think. I think that was it from this introduction.
Okay, thanks, Niklas. And let's move to demos. So we are going to demonstrate these core functionalities which Niklas just presented. And that means that we are going to demo user account registration in EGA portal. So user is going to fill in the registration form and select the local EGA instance which he or she wants to submit the data. And after that, we are going to show file encryption and upload mechanism to local EGA SFTP inbox. And after that, we will show metadata submission in EGA submitter portal. And in that submitter portal, we are linking the metadata to the files which were uploaded to local EGA. And finally, we are going to show file access. So we are going to show how to access these files which are archived in local EGA, and authentication will happen using Elixir AI access tokens. So first one is the submission part, and Brett will present that one.
Yeah.
Go ahead.
Morning, everyone. So I will give you a little overview now of the structure that we have done for file ingestion. So assume that we have central EGA on one side, local EGA on the other side. For example, Sweden. We will take Sweden as an example here. And central EGA would be EBI or CRG. When we want a user to submit something, there are the encrypted files and there are the metadata. And ideally, when we do a Swedish submission, as an example, the metadata will go to central EGA and the encrypted files should go to local EGA. The encrypted files, they should end up in an inbox so the user will submit.
We are not going to update my Mac at the
moment. So when the user uploads the metadata to central EGA and uploads the encrypted file to the inbox, we have some sort of mechanism that where central EGA, when they send us a trigger, the goal is to actually re-encrypt the file and put them into the vault. So we should, of course, decrypt the file and then re-encrypt the file. Now, there is one more step, which is that when there is yet another user into the picture, they would like to access the data. So this is the last part where we will show how to get the data. So on one side, we have Spain and Sweden. For the example, this is where the front end is in Spain, the submitter portal. So that's where they're going to log in. And then in Sweden, we have the inbox and the vault. Now, we have connected the two systems through message queues. And messages are piled up. And then we also have message queues in Sweden. So they are there are different queues, one for ingestion, one for errors, one for which files are in the inbox, and so on. And we also have one system of queues, and then we connected both of the system together using fault tolerance. And it was quite of a challenge already there to get it secure so that we make sure no message are lost, and we could get over the network failures and stuff like this. So assume that at the moment, the user would see a web page on the front end that shows a list of files, and they would like to upload new files. So the first step they do is that they have to log in onto the inbox so that they can upload the files there. And one of the challenge was to actually make sure that the user list and the credentials comes from somewhere in a way that we don't have user accounts and passwords that are different from one country to the other one. And so, and if we have to revoke some passwords or some access, we will have a nightmare there. So instead, we have made a custom system that checks the credentials from central EGA. So there is a central place where all the credentials are, and then we connect to this central place. Number two, they upload the files. When they upload the files, we would like to, of course, have isolation so that a user will never see the file of some other user and could compromise their files. And then the last thing we have done is to have automatic notifications. So when a file is uploaded, there is an automatic mechanism that says to Central EGA that there is a new file so that it can show up in the front end. So the notification goes through our messaging system, it goes through Central EGA, and then it shows up in the web page. We will demo that live, but here I'm giving you an overview. When the final step is when the user wants to link the metadata and this file that just uploaded. So they click a button, and then we send a message to the queue. We find it in the inbox. We encrypt it into the vault, and then we send a message back to Central EGA stating that everything went fine or there was an error, and voila. So there is one more thing into this system that is quite interesting, is that if there is a new player into the picture, say for example France, then it's very easy to make a new connection to Central EGA and have everything which we described for Sweden already in place for the new country. So the user list credential, the isolation, the notification, all of that already works. So this is what we call automatic. This is fantastic. So, so now a bunch of demos. So we have 3 demos for this ingestion part, and then 1 demo for the data apps part. So assume that we go to this test front end for user registration. So now we have a new user, and they would like to submit something, so they need to register. They go to the page, and then they see this form. So they start filling in their data, and here we're going to use a very fancy user. So John Travolta is going to be the new user at EGA, and they come from the Time Warner company. Whatever, I just filled in some rubbish data, and they say I would like to be called John. It's subject to availability, and you didn't know, but John Travolta comes from Sweden. So he wants to submit some sequence, and they say they would like to connect to Local EGA 1. In our case, Local EGA 1 is just a fake name. It will be called Sweden, and Sweden Stockholm, or Sweden Göteborg. So you fill in, and then of course we have to grant access permissions, and then they get a ticket. This is what they get. So what happens is that ideally, when they have filled in, it sends a message as an email to the help desk. And at the moment, this is manual work, but later it will be probably automatic. And the help desk will actually create the user account and the credentials. And the help desk decided that John was not available, so they called this user EGA box 999. So after that, they get those credentials, and then they can log in onto the front end. So now they need to upload the files to the inbox. So there are 2 parts. They need to encrypt the file, and they need to to send the file to the inbox. To encrypt the file, we use PGP. This is a standard for encryption, and there are tools that encrypts for PGP. So GPG is one of the tools. EGA Cryptor was available already, and you can also use other tools because this standard is standard. For the file upload, you could do it with a command line using SFTP command line, or you could use it using FileZilla as a graphical user interface, and this is how we will show how it's done. But for the encryption, there is one thing that is very important, because right now we have different locations, and each of them should have their own encryption, so that when we encrypt the file for Sweden, Finland cannot read the files. So what's important is the keys. So this is why we have created this LEGA cryptor, so Local EGA cryptor. So that encrypts the file given where you want to send them. So here's a demo of the encryption part. We have this file called HG blah blah blah, and then this folder that is empty at the moment. So now this LEGA cryptor, I'm going to output the help, so that you see that you can submit which recipient you want to send it to, and you specify that the recipient at the moment, say it's called Sweden, and it will look at the list of keys that are available and then find one that says Sweden. and the output will be into this directory, and it will output 3 files. One which is the file that is encrypted. This name, this file will be encrypted. This HG something. It's encrypted, and it also will create 2 extra files that are checksums. One checksum is to verify the original file integrity, and then another checksum for the encrypted file integrity. So these 3 files are the one that we will upload into the inbox. So the next part was the upload. So we have now this demo sample one directory with that represent the encrypted file for this one. So this file is the original file, but Dimitro is going to show it in a different way. Now those 3 files are going to be uploaded. One is 80 meg for the moment, and the other ones are very small. The checksums are just there to verify that when we upload something, everything has been uploaded, so that we can double check that not half of the file has been uploaded. So now let's open FileZilla, and I have the files on my desktop, and I have preset already that EGA box 999 is the user, and then we are going to log in using a key file. We support passwords and we support key file. You already know passwords, so I'm showing key files. Now we log in, and as you can see that the user sees that they are in root. So they don't see anything else than their own directory, which is good for isolation. Now we upload, and I'm going to show you what happens on those message queues, just to see that something happens. Now we have uploaded, and you see that automatically Central EGA on the top part, Local EGA on the bottom part, but Central EGA on the top part has received 2 checksums already. In the file transfer, we have transferred the 2 checksums and the inbox file. So in the inbox message queue, they have received one, and then they have received automatically the checksums as well. The checksums are important so that we can make sure that the file is full, so that we didn't upload half of the file. So that was the upload, and now we're going to the last part, where the user goes to the submitter portal and decides that there is a given run of some experiments, some sample data and things like this. So they are submitting the metadata, and then they go to the list of files that they have, and they link those files. So they log in, and onto the submitter. We are still on the test portal, but they log in onto this page, and then they see that they have given submissions there. So we have this test that already was pre-created. At the bottom, you see that these are the list of files, and the demo sample HG something has arrived, and the checksum. Now, on the right, you see that there are files from the Lega inbox, and then also some EBI. So you could have a mashup with different locations if they have granted access to these different locations. So now we're going to link this experiment and this file. So it's a BAM file. We have a sample. This data is already pre-filled for simplicity. But then we select the file, and we click on the save link. Now I'm going to show you that something happens into the message queues. And on the top left, you see the message queues in Central EGA. And you see that one file is currently processing, and we are waiting. You see that some files on Local EGA have been received. And the bottom left part is that I wanted to show you some output that something is happening on the machine. So, and there we got the message back that the message is complete. The file is complete. So one of the messages, somebody needs to be muted. Oh, there. So when the message has arrived in the queue, we actually have this state that says everything is fine and it's completed. And then there is this stable ID, as we call it here. So a final name to refer to that file. This stable ID will be the one used by Central EGA, and it refers to different locations in different countries. Now, in the list of files there, you see this one, the bottom one has shown up in the list that of files that have been ingested about a minute ago. So this is how it shows up. Now we have some some improvement to make to the front end so that it shows more than just one file as a route. Maybe it should show a little bit more information about the file, especially in case of errors. But this is how the link from the metadata. So ideally, we would have the list of files, and then boom, boom, we would show something like the file is ingested, and this is the name that we will use in Central EGA, and then it shows up into the how do you call it, the search engine, where they look at the files and want to refer to those files. So this was the part, and now you can go on to the data out demo.
Thanks, Fred. So now we have archived and dataset and files to local EGA. So metadata is in central EGA and files are in local EGA. And the data distribution model in local EGA is exactly the same what it is in central EGA. So a user who wants to have access to this data is going to request the access, and applicants are then referred to relevant data access committee, and then central EGA, data access committee is going to check the admission to the data and preferably grant access to the data, and then user is going to or actually central EGA is going to update the user account so that this user account has access to this data. So permission information is updated, and then files are provided to the user. And in our case, in local EGA's case, this permission information, data access rights is stored in access token, and that access token is provided by Ledger AI. And now we are ready to move to access part. So, Dimitri, are you ready?
Yeah, thanks.
We can click on the YouTube link there. Okay. Yeah, and now you can go full screen. There we go.
Here we go, yeah. So now we are going to look how the data out works. We have our file ingested, hg something.bam, and we have stable ID of this file. We want to get it out. So we check if the data out system is up and running. It is. We have a bunch of microservices here. We have our JOT token obtained from Elixir AI with the grants to access this file and the authentication information. And we have stable ID that Fred showed we retrieved while ingesting this file. With these two things, we can query the REST endpoint, HTTP endpoint, to download this file. Firstly, we're going to download it in unencrypted way, just to see that it's possible, and then in encrypted way. So we downloaded the file, and we see that contents matches with the original file. This is the BAM contents of what we uploaded and what we downloaded. The files are identical. It's a bit too fast, but yeah. Now we're going to download the re-encrypted file with PGP re-encryption. Can you pause for a second? I will explain a bit more. So to look at the format of the URL, we have header with a token, we have stable ID specified, yeah. Thanks. And here we add destination format, which is GPG asymmetric. It can also be symmetric with a passphrase, but here I'm demonstrating asymmetric way with using keys. And the destination key, in this case, it's the username. So we're going to re-encrypt this file for the John Travolta user, so he can get his data back. But we can specify any registered user that has access grant by data access committee. Let's go further. We're downloading the re-encrypted file. Now we will see that it is really re-encrypted. meaning that it's binary. Here we go. Some binary unreadable content. And now we're going to decrypt it with the standard GPG tool. I have the key for the John user in my local key ring, so I can just enter the passphrase for the private key, and the file is decrypted locally for John Travolta. And now we can see the decrypted content, and we can check that it matches with the original file again. So we have headers identical and contents are identical fully as well. That's it. Thanks.
Next video, please.
Yeah. Thanks, Dimitro. So now it's showing the video. So now we have demonstrated the ingestion, the archiving part, and the access part. And about the implementation is open source, and source code is available in GitHub. Ingestion part is done using Python, except that authentication part is actually BAM module, which is written using C. And Local EGA crypto part is a separate tool, which is also written in Python. The data out part uses EGA data API, which is done by EBI, and we have done some modifications on top of that. So this repository actually points to Local EGA fork of that EGA data API, but the EGA archives repository is almost up to date, so we only have some minor changes left in our forked repository. We also have public documentation which explains that how this thing works and how it can be set up. And we have public continuous integration tool, and we have tests so that we can make sure that when we make some changes, we will not break anything.
Let's break the world.
So what are our next steps and future plans? At Next, we are going to focus on deployment things. So we want to deploy this to real production environments in Finland and CSC. We are going to deploy this on Kubernetes. And in Sweden, they are going to use OpenStack Cloud and Terraform deployment method.
You should say we do have deployments, but for tests, we want real case deployment.
Yeah, that's correct. So we actually haven't done something related to this, so we're not starting from scratch. We already have some kind of deployment methods. In development environment, we just use some Docker images and Docker Compose. And we are also going to focus on metadata mirroring. So we want to mirror that metadata which is currently stored in central EGA in local EGA as well, so that we can have a copy of that metadata about these files which we have archived in local EGA. And in Trupe 2 project, we have 2 milestones for this year, and the first one is REMS integration. So we are going to integrate REMS system so that we can manage access permissions to datasets which are not part of EGA. And this is related to plan that we want to also archive some datasets to local EGA which will not be submitted to EGA. And the last milestone for this year is that we want to have at least one dataset archived in one local EGA instance before end of this year. And I guess that that's it. We have some time for questions, so please go ahead.
You can stop sharing the screen.
This is Peter from the Netherlands. I have one question. Early in the demonstration, when the user registered at the central EGA website, he had to specify which local EGA instance to use. It was named something like Lega1 or something. It was just a very short name. But then later on in the demonstration, when the encryption tool was used, you had to specify something like the key with -O Sweden. And that, I think, if I got it correctly, that was also for the local EGA instance. So how does a user know that this Sweden is this Lega1?
It's a misnaming on the website. They, in the mock-up, in the test, they call them Lega 1, 2, 3, 4, and then we call them Sweden and Finland and so on. So it's just, it should be the same name.
Okay, but is there somewhere a list of local EGA instances and what their name is? Or, I mean, how does a user find out what to choose or which local EGA to use?
So the list on the front page should be dynamically updated with exactly the same list of local EGAs that are local instances that are deployed, so it should match.
Okay, check. That's clear. Thanks.
Peter, this is Jordi Rambla from the EGA. Keep in mind that a user could not decide on himself that they want to send something to a local EGA. The local EGA should accept this user as a legitimate user for this facility, okay? So there isn't a step in the middle that we need to tackle down a little bit with the different local EGAs to see which is the acceptance policy of the user. So this is something that needs to be tackled down. Most of the legal agreement and these kind of things is still in the works and would come later.
Okay, clear. Thanks.
Peter, to describe the little step in the middle that Jordi talked about was that at the moment that the help desk receives an email, there is a manual work now that they create the user credentials, but they also check with the local EGA instance that if that user gets access to Sweden or to the particular local EGA instance, and it's not an automatic step at the moment. So if they get access, then something is added to the database that says this user has access to Sweden, but not Finland and Romania and so on. And when they try to log in, our automatic mechanism will check whether they do have access to Sweden or they don't. And that's this middle step in the middle that is at the moment not automatic.
Okay.
Am I making sense?
Yeah, that makes sense now.
Yeah, and about that public key authentication, in that demo we use public key authentication, but as Fred mentioned, we also support password, so user can use the same password for logging into local EGA.
Okay. Any more questions?
So thank you, gentlemen, for this nice demonstration and for all the work you are doing. Okay, as this is moving forward, probably thanks to the Nordic countries' contribution and so. And I would like that the central EGA could go faster in providing you with everything that local EGA is requiring. It's coming, but not at the velocity that I would like to have. Having said so, let me say that in the next steps, we are also planning in several things. One of them is applying quality control to the files that it's not currently being done. And this is relevant for anything that you want to search later, as for example, if a given gene is covered in a file or not, and to which degree, and for you to check which is the overall look and feel of a given file, okay? And also that all the phenotypic part, the clinical thing that has been described for the things that are not going to the local EGA, it's also on the radar of the solution, moving from an integrated ecosystem thing to something that could be deployed independently of the EGA itself, but providing, leveraging, powering the technology that we have been developing and the expertise that is in this solution. Okay, so just a couple of comments on that.
Thank you, Jordi.
Yeah, thanks, Jordi. Well, if we don't have any questions, I think that we can end the meeting. So thanks for everyone for joining, and goodbye.
Thumbs up.
So local EGA development team will continue to sprint planning meeting, but I guess that we could have 5 to 10 minutes break before actually starting.
Okay. Bye, gentlemen.
Bye. Thanks, Jordi.
Bye-bye.
Thanks, everyone. Bye.
Of the recording.